Well, as you can see here, this is also a very famous problem. But what I'm doing in these problems, what I'm doing with these famous problems, that I'm giving you my angle on them. Uh, I'm not solving them because they are solved somewhere. I'm giving you my angle on those problems. I'm old enough. I have lived with these problems, failed, solved, failed, thought, again solved, and by observing for years or teaching them for years to various people, I've gained some what is called experience, and that I'm giving you. You can see there is a problem, and this is no. This says like there are two bars with masses m and m. Okay, you can see here are lying on a horizontal plane, connected by an undeformed spring. The coefficient of friction of the bars on the plane is mu, not mu1, mu2, but it doesn't matter. What is the smallest constant? Smallest. I'm using the word smallest. I I have used the word least, greatest and least, but talking physics, I got my freedom from the subject, and I'm using the word smallest. What is the smallest constant horizontal force that must be applied to one of the bars to move the other? फोर्स एक पर लगाना है, मूव दूसरे को करना है, और बीच में एक स्प्रिंग है जो कि नेग्लिजिबल मास का है, हुक्स लॉ ओबे करने वाला है. सो गेट रेडी. नाउ in order for this block capital M, block of mass capital M, to move from its place, we have to apply a force on it, and this force will be applied by the spring, the Hooke's law obeying spring, and it is going to apply a force like kx, and to move this block of mass capital M from its place, we will be needing a spring force that is greater than equal to mu mg. In the limiting case, it is equal to mu mg. Okay, so we need to extend the spring, and we can not extend the spring until we apply a force on block of mass capital M. So suppose we moved the block, and तो जैसे ही हम block of whenever I will try to move the block of mass small m, a friction force will appear, and it will be the force of kinetic friction, because I am really going to move it, because I need the length of the spring to be extended. So I will be moving the block of mass m1, mass a small m. So force of kinetic friction is going to act on it, and the force of kinetic friction on it will be equal to mu mg as well. And two forces are working on in this case two forces are acting on a block of mass m, and two forces are acting. The first force is F, and I need a displacement, I need a length x of the spring to be extended. So I will be moving the block of mass m by a length x. दैट मीन्स लेंथ एक्स तक मूव करना है इसका मतलब कि ये जो फोर्स है कैपिटल एफ, इट इज़ गोइंग टू वर्क एफ एक्स सिंपली इस दौरान, और इस दौरान इस पर जो फोर्स लगेगा काइनेटिक फ्रिक्शन का, दैट इज़ गोइंग टू वर्क लाइक माइनस म्यू एम जी इंटू एक्स, और ये दोनों फोर्स मिल करके इस स्प्रिंग को लोड करेंगे, स्ट्रेच करेंगे. सो what I think in solving such problems, that as a method we should apply this condition, that the work of force F, I'm going to write down it. In solving all such kind of problems, I use a method that is based on first law of thermodynamics, and that I am providing you that the work of force F, जो force required है, and the friction force, and is equal to change in potential energy of the spring. अब की बार पॉजिटिव चेंज हो रहा है बिकॉज स्प्रिंग इज बीइंग लोडेड. चेंज इन द potential energy of the spring, a spring of the spring. And if I write this equation, it will simply comes out like fx minus mu mgx, and that will be equal to half kx square by 2. And you just put here that kx was equal to mu mg. You need this. So x 1x will get cancelled out, and then kx की जगह पर अगर आप कैप mu mg put कर देंगे, you will get your f, and f will come out like mu g m plus m by 2, and that's your answer. So mu1 ho, mu2 ho, you do not need to worry about. This is the simple method, and the first law of thermodynamics is a useful tool. I wish I could have treated the subject along with work, power, energy, but I tried once the expression of first law of thermodynamics using work energy theorem, and that was correct too. And I will introduce to you pretty soon. Thank you very much for watching right now.